Big data refers to large and complex data sets containing information used by scientists, business executives, doctors, marketing agents, and governments. Data is collected from mobile devices, software logs, cameras, microphones, and other wireless sensor networks and stored in large databases. The International Data Corporation predicts that there will be 163 zettabytes of data collected by 2025, which is 6.3 times 10 to the 13 gigabytes. These massive volumes of data are difficult to manage with traditional software, and thus large databases are required to store all of the collected information. Big data can be characterized by the three V's, namely volume, variety, and velocity. The volume of a data set refers to the literal size of data being analyzed. Much of this data can be unstructured or of unknown values. The volume of data can range from tens of terabytes of data to hundreds of petabytes, depending on the amount of inputs received. The high volumes of data can be left in a raw form or processed using data mining or data preparation softwares before analysis. The variety of big data refers to differing types of data that are available. Due to the various forms of collecting information, data may be unstructured or semi-structured. Examples include text files, audio files, sensor data, or video files. The different forms of data require processing in order to derive meaning and analyze information sufficiently. The velocity of data refers to the speed at which information is generated, processed, and analyzed. In many cases, big data must be analyzed on a real or near real-time basis. For example, Facebook users upload nearly 300 million photos per day, and the Facebook software must process, file, and retrieve each image as quickly as possible. The ability to automatically find patterns and analyze input data is necessary to constantly generate new insights for any company. As big data becomes a more prevalent tool used by businesses, the value and veracity of the data collection process becomes more and more important. The value of collected data refers to the relevancy of the data to a business. Organizations will often cleanse data and use the most relevant parts to make business decisions. The usage of incorrect or irrelevant data can weaken insights provided by analysis. Additionally, the data collection procedure may be influenced by a degree of uncertainty. The veracity of data refers to how truthful or accurate the collected data is. For example, raw data collected from social media platforms and web pages can lead to serious data quality issues. Collected bad data leads to inaccurate analysis and a lack of trust in the collected analytics. In order to combat this, big data analytics teams ensure that enough accurate data is available to analyze and produce valid results. The storage of big data requires a strong underlying computing infrastructure. Sufficient computing power is required to quickly process and analyze incoming data. In order to reduce costs, businesses have turned to public cloud computing systems in order to host big data. This allows corporations to store their data for the duration of analysis without having to purchase a large server system for computations. These public cloud systems, such as Amazon Web Services, Microsoft Azure HD Insight, and Google Cloud Dataproc, offer big data capabilities for businesses to draw inferences from their data sets. The usage of big data does not come without its own challenging set of problems. A major issue is that large data sets are often extremely complex and expensive to analyze. This makes it very difficult to generate valuable insights without a targeted business strategy for gaining information through big data analytics. Additionally, the collection and usage of private data by businesses to generate insights leads to issues with privacy and security, as a person may be unaware that their information is being constantly collected and analyzed. Overall, the implementation of big data analysis allows for researchers and businesses to make better and faster decisions. Using specific techniques, such as text analytics, machine learning, predictive analytics, data mining, and natural language processing, businesses can analyze new sources of information along with existing data in order to make more informed and reliable decisions.